Okay, so we reviewed the syllabus, took a look at where we are. I also there were a few people, a few students who were still struggling with some of the energy concepts, the units concepts. I want to go over that again right now in preparation for the midterm. One false assumption that I made going into this course is that everyone had already taken NRGY 101, and that's a lot of people had already taken NRGY 102. Obviously, that's not the case. This course is being offered both through the Energy Technology program and through the Environmental Studies program. And a lot of times in Environmental Studies, they're not taking an engineering mathematics approach to some of their things that they study. So I'm going to review that again briefly because it wasn't, some of these concepts were not picked up by all of the students who are taking this through the environmental studies. And I also heard, this is a little bit disappointing, I won't name any names, but I've heard a few other students saying, hey, I was trying to avoid watching the YouTube videos. Well, there are 14 or 15 students in the class. I know a lot of, everyone is not coming to lecture because of other obligations, but if you're not coming to lecture, it is your obligation to listen to the lectures on YouTube. To say that I was trying to avoid watching them is like I was trying to avoid getting a passing grade in your course because I didn't know what was going on because I didn't listen to lectures. So that's not something you want to tell your professors, like I was trying to avoid watching. Sorry, that's part of the class. Okay, so don't say that even if it's true.
Yeah, was not to say.
So let me re-review one of the questions from Quiz 3. This is an invaluable skill to have, and I'll tell you why. I'll tell you exactly why. I'm going to go right back to a talk that I gave in Billings, Montana last month, Conferences 2015, NCAT Billings. This is my talk, and I start most of my public lectures with a quote from this guy. Kerry Mullis won the Nobel Prize in the mid-90s because he invented PCR, which is the process by which we can take a tiny fraction of DNA and more or less tell exactly where it came from, amplification. And he was sort of looking at the state of science and saying, we spent a lot of time, money, effort trying to solve problems that have no impact whatsoever on our species. And I love the last little thing. We are mammals, and we have not exhausted the annoying little problems of being mammals. First of all, living on planet Earth with sufficient food and shelter. That's not the one I wanted to show you. This is the one that is more important. Lord Kelvin, previously last name was Thompson, said that unless you can express yourself quantitatively, you might think you know what you're talking about, but probably you don't. And I see this happen a lot of times, especially in the environmental studies circles. You sort of go round and round and round, and you kind of end up getting in your own way and ending up in sort of this stalemate situation where everyone's standing around, for example, watching forests burn and elk get barbecued and the surface of the planet get turned into the moon because we can't actually measure what it costs to preemptively prevent a forest fire rather than come in August and put in these little tiny efforts to put them out. So long-winded saying, you got to measure things. So one of the problems on Quiz 3 was to look at the amount of thermal energy coming through a waste stream. So what we started with, and actually let me go right back to the question that I posed in Quiz 3. Because almost any problem, whether it's accounting, business, recycling, is going to come down to these few little fundamental skills that I'm going to show you right here. And I tried to make the quizzes, at least this first time through, as simple, straightforward as possible. Okay, so given that a hospital disposes of 1,000 kilograms, that's 1 metric ton, by the way, of waste per day, and that the energy density of solid waste is 10 megajoules per kilogram, how much thermal power could the unit generate? For those who've taken 101, what's special about 10 megajoules? I'll show you. You got to think about 10 megajoules every single day, because 10 megajoules is how many joules it takes to keep one human being alive for 1 day. It's 20. Well, it's not a survival rate. It's sort of the USDA recommended. 2,500 kilocalories is one daily human metabolism. So if we could in fact eat garbage, we would only need 2 pounds of it a day to stay alive if we had the proper enzymes in our digestive tracts. And we don't, even though our metabolisms are this complex, we can't yet process our own waste. Okay, so back to the problem. 1,000 kilograms of waste per day, 10 megajoules per kilogram. How much thermal power, and this gets back into a building energy efficiency questions, how much thermal power could we make to keep the hospital warm when it's cold and snowing and minus 20 outside? Well, let's break the problem down with some very simple algebra. So what we're looking at is writing down in the numerator 1,000. And what is 1,000? Well, it's just a number, and that's why I put the number symbol up here. 1,000 is a number. The K, it means kilo, and that's just a power of 10, so I put the number 10 here, saying that's what that K means. And then the gram is the unit. So in any problem where we are following the instructions of Lord Kelvin, we are able to quantify what it is we're measuring. We've got 1,000 kilograms of garbage per day. Day is also a unit. It's a unit of time. So in any one of these problems, we're solving 3 problems at once. We're keeping track of the numbers, we're keeping track of the powers of 10, and we're keeping track of the units. And they all 3 have to work out if we're going to get the answer to the problem. So I also just told you in the problem statement that there are 10 megajoules of energy per 1 kilogram of waste on average. Right, so paper's going to have some value, plastic's going to have another one, metal, that's not going to be combusted, so it's going to have none. Water in the waste stream actually reduces that because you're looking more at what's called the lower heating value instead of the higher heating value. If you get it hot enough, you can then turn that into some kind of steam, etc. But in this case, we're just doing pyrolysis. So I've got megajoules in the numerator, kilograms in the denominator. That allows me to cancel kilograms. What am I left with? Well, I've still got the number 10 here. I've still got megajoules for the time being, so just follow what's going on in the red. I've got megajoules per day. Now, I know in general when I'm talking about power, when you go and look at your electricity bill, you're looking at things in terms of kilowatt hours, right? So what I want to do is move away from mega, and I want to get to kilo. I want to get to this power of 10 that's order of magnitude 3, and get away from this power of 10 that's order of magnitude 6. So I know that there are 1,000 kilojoules in 1 megajoule. So now I've been able to get rid of megajoules, and now I've got kilojoules per day. That's what's still left over. And now all I need to do to get from kilojoules per day to kilowatts is realize that one joule equals 1 watt times 1 second, or 1 kilojoule equals 1 kilowatt times 1 second. So if I then say that in 1 day there are 24 times 60 times 60 seconds, I can then get rid of days here, days here. The only thing that survives now are kilojoules and seconds as my units. So I've got kilojoules and kiloseconds, or sorry, kilojoules and seconds, and now I know that I know that 1 kilowatt equals 1 kilojoule per 1 second, and I'm very confident now that whatever number pops out of here, remember that was the first part, keeping track of the numbers. I've also kept track of my powers of 10. I've gone from mega to kilo, and I've dealt with my units by doing a time conversion to get from days to seconds. So now that I'm confident that my powers of 10 and my units are correct, I can just come through and do the very light work of a little bit of arithmetic. So 1,000, which is right here, times 1,000, which is right there in front of kilojoules, divided by 24, divided by 60, divided by 60, equals 11.5.
Yeah, what about that 10 megajoule?
Oh, yeah, times 10, thanks. And times 10 equals, there we go. Yeah, thank you. I left out the 10, but there that is. So, yeah, it just becomes an accounting exercise, and I've got 116 kilowatts. 116 kilowatts. There's the answer. 116. Next. Answer saved. Submit and finish. Submit and finish. And if I go back into my grade book, hopefully I got the answer right. But hopefully now we've also seen that we've satisfied Lord Kelvin, because now we can go tell, what's his name? Jeff Fee, who's the CEO, director of St. Pat's, exactly how much thermal energy we can pump into his HVAC system, so he does not have to purchase fracked natural gas, etc., as a non-renewable resource. He can use his renewable waste resource as a heat source for his hospital, and he can put that into dollars and cents, which is his bottom line, which is the ball and chain that our civilization has built for itself, money. Okay, so I hope that kind of puts the big picture into perspective. Well, the little picture and the big picture. We did the problem, and we're able to go in and provide a sustainable solution that can also be monetized. All right, any questions on that at all? So that's a skill I want you to come away from this class with. We do it night and day in 101 and 102. It's what's going to make you a more valuable employee as a recycling technologist than an energy technologist. If someone says, yeah, save the trees, save the planet, go Greenpeace, et cetera, et cetera. I mean, our job here really is the energy technology program is to provide quantitative solutions, to the problems that are typically identified by the climate change and the environmental studies folks, and that are negotiated and pondered by the communication studies and the lawyers. Okay, let's take a break there, and I'll just show you what to expect on the midterm. I'm launching it here in about a half hour, so you'll be all set for that.